Okay, so time to do the graphs of the sine and cosine functions. We'll do the tangent, I guess, on Thursday. All right, so sine and cosine. Some of your calculators, if you put it in the right mode, it will actually give you the graph of the sine and cosine. What you first off have to understand when we're doing the graphs is what the axis represents, right? So you can see the x-axis is the angle, right? The x-axis is the angle, and the y-axis is the actual trig function. So again, what is y equal? So you can still think of it as a y, but what is the y? It's actually the ratio. So the horizontal axis is the angle, the vertical axis is the ratio. All right, so let's go through and graph the sine. So take your calculator, punch in 0 and hit the sine button. Punch in 0, hit the sine button. And your calculator says 0. All right, so we're at 0, 0. So go ahead and plot the point 0, 0. Punch in 45, hit the sine button. And you got 0.7071. All right, let's see, where's 45? Half of 90, so 45 is right there. And so 0.707, about there, roughly, right? Halfway between 0.5 and 1. 60 degrees, 0.866. What's the fourth digit? Oh, okay. 0.8660. And again, we're 60, 2/3 of the way along. I'm not even going to plot that one. I just want that value there. We'll show you when we get the curve. And then what is the sine of 90? Sine of 90? 1. All right, so we're up to 1. Go ahead and do sine 135. So again, you punch in 135, hitting your sine button. Calculator says? All right, 0.7071, and again, 45 is halfway between here, so we're back to there again. And you see we're coming back down, right? Wave is on its way back down. Punch in 180, and you get 0. So 180 is 0. So let me let you catch up. By the way, notice in all of these, I'm giving you the radians out to the left as well. 0 degrees is 0 radians. 90 degrees was pi over 2. I'm just giving you the main ones. 180 is pi, right? Sometimes they're going to ask you to graph in radians. The book mostly asks you to graph in radians. I'm trying to use degrees first because you think better in degrees than you do in radians. But you got to tie the two together. Okay, that's only half a wave. We got to keep going. So sine of 270 is -1. So go down to 270 and put a dot at -1. And then finally the sine of 360 is 0, and you're back up to 0. All right, so the main points are the points in the blue boxes. If you're going to learn the sine wave, you need to learn the sine of 0, the sine of 90, the sine of 180, sine of 270, and the sine of 360. And you do have to learn this pattern. This is something that you should memorize because it's the pattern that then allows you to do all kinds of different variations. We've dealt a lot with transformations, right? And we will transform the sine and cosine functions as well. All right, to finish this thing off, you got to do this thing with a smooth curve. I've seen people write their sine waves and they look like V's. Well, I tried to spread it out enough to where it won't look that way, but try to connect all the points with a smooth curve. And then you have an arrow technically on both ends because this thing keeps going forever and ever. Key point is the crest. Which would be the max point on the graph. What would you call the minimum point? You have a crest and a trough. T-R-O-U-G-H. Notice the other key, so the crest and the trough are key points, really important. Max and min points, right, of the function. And then think about these points. What would we call these points? The zeros, right? The zeros are important. So the zeros are important. So what we're doing right now is we're representing the sine function in a horizontal view, in a Cartesian plane, with the x-axis representing the angle measure and the y-axis representing the ratio. That's the idea. Let me see if this will cooperate with me, for me. All right, so here's an applet. And there's no way we're going to be able to see both. Man, it's really sluggish. Wow. Like I'm not even touching it and it's moving. Huh. It went away. Where'd you go? Oh, now PowerPoint's going to come up. Great. All right, so let me get back to this applet and see if it'll cooperate for me. When we were talking about trig in a Cartesian plane, thank you, PowerPoint. Go away. We don't want you. When we were talking about trig in a Cartesian plane, remember when we said the sine, of course, opposite over hypotenuse. However, if you talk about a unit circle, the opposite is the y-coordinate, and the hypotenuse is the radius, which is 1. So the sine is just the y-coordinate, right? So this view is the radial view. You're going round and round. The other view is kind of that horizontal, stretched out view. So if I take, yeah, okay, it's going to work. So did we do what? We did the sine of 45, right? So I'm going to put that at 45. And if I were right at it, I'm close. Let me get to 45. The sine of 45 was what? 0.707. And I'm at 44. Come on, 45, okay? And there's the sine, 0.707. Now, let me see if this will cooperate. No, that's not what I want. If you were to look at the coordinates of the point, go back here. If you were to look at the coordinates of the point, the x-coordinate would be 0.707 for the cosine, and the y-coordinate would be 0.707 for the sine. If I move this around to 60 degrees, then the sine is 0.866. If you had the coordinates of that point, listen now, if you had the coordinates of that point, the x-coordinate would be 0.5, right? The value of the cosine. And the y-coordinate is the value of the sine, 0.866. So again, this is corresponding to our curve, right? We're right here on the curve right now. You know, there's the sine wave in red that we just drew. So if I get up to 90, now we're up to 1, right? And now as I'm coming around past 90, I'm coming down the curve. There's 120. There's 135 that we graphed, right? And I'm coming around the curve till I hit 0, right, at 180 degrees. And then we start heading below the curve as we're coming down and around. And again, in red, you keep seeing the y-coordinate of this point around the circle, right? You keep seeing the y-coordinate, y-coordinate, y-coordinate's -1 right there. And then we're coming back up around and coming back up and around. The correlation between the round view, the rotary view, and our stretched out horizontal view. And that's what you need to try to keep, that there's a correlation there. And that's why I have the drawing below of the radial view as well. Okay, so with this, that's one complete wave. This wave keeps going. And let's see, I'm just, you know, again, this thing keeps going back that way. This thing keeps going on this way forever and ever. It goes backwards forever. It goes forward forever. Say, how can that be? How can it go backwards forever? How can it go forward forever? Okay, so just watch. Oh, let me get my pen. Thank you. We'll get there. So, all right. So go away. Technology. Love it or hate it. Okay, so watch. There's the first wave, right? What if I keep going? Now I'm into my second 360. Now I'm into my third 360 degrees. Now I'm into my fourth 360 degrees. Now I'm into my fifth. All right, start back at 0. What if I go backwards? Now I'm going negative 90, negative 180, negative 270, negative 360, and I'm going backwards. And I can go backwards forever because it's just a wheel. It's just round and round. You can go backwards forever. You can go forward forever, no matter which way you're looking at the view. Backwards forever, forward forever. So this keeps repeating and repeating and repeating. One wavelength is the length of one wave. Right? One wavelength is the length of one wave. And it's also called the period. And the period is 360 degrees. And what is that in radians? 2 pi. You need to keep coming back to radians and think both ways to start getting used to thinking. So we're showing one wave from 0 to 360, and that's the normal sine wave. That's one wave, complete wave, 0 to 360, and it repeats. Next, from 360 to 720, repeat. From 720 to 1080, repeat. From 1080 to 1440, repeat, etc., 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 etc. All right, so again, in the box, the key values. Sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is negative 1. Sine of 360 is 0. You should learn that. Those are the key points of the sine wave. And those are the ones that you're trying to learn. All right, so you go to this cosine. And let's see, let me get rid of, we don't need the radial view. I'll just pull up the applet when I need it. Okay, so cosine, again, key points, 0, 90, 180, 270, 360. Same thing, same key points. I'm going to do these in green. So punch in 0 and hit the cosine. You do not get 0. You get 1. So take your green and put a point at 0, 1. Right? So you're up to 1 on the y-axis. Punch in 90, hit the cosine. Your calculator says 0. So now we're down to 0. Punch in 180, hit the cosine. Now you're down to negative 1. Punch in 270, hit the cosine, back up to 0. Punch in 360, hit the cosine, back up to 1 again. This one's a little harder to draw. So again, now we need to connect this with a smooth curve. And the more stretched out you make the degrees, the more stretched out it looks. Look, I could scrunch this up real close if I don't stretch out my degrees, right? I can scrunch the appearance of the wave. It's just like taking a photo and scrunching it up. Okay, so understand that this thing goes on forever both directions, right? Same deal. Goes on forever in both directions. Key points. What are the crests? It crests at 0. It crests at 360. The trough is 180. What's the period of the sine wave, or of the cosine wave? It is also 360, which is also 2 pi. All right, I hope I drew these the same. So let's see if I can do this. Let me see if I can grab the sine, if it'll let me have the whole wave. Maybe not. Yeah, all right, let me do this. I'm going to trace over my sine here in purple. Okay, so that's the sine wave, right? All right, let me take that sine wave and pull it down here. See how close they were. Not too bad. A little bit off on my drawing. So do you see how the cosine wave is really basically the same shape as the sine, but it's, we say, 90 degrees out of phase. It's really the sine wave, but it's 90 degrees further ahead, right? If I take this sine wave and move it, 90 degrees back. It's got to go 90 degrees. If I go right, take the sine wave here, right, just like that, that would be the sine. Take that sine wave and go back 90 degrees, what do I get? The cosine wave. Okay. And again, this is the relationship between the sine and the cosine. And this is that relationship where the sine of 10 equals the cosine of 80. The cosine of 20 equals the sine of 70. Right? The cosine of 25 equals the sine of, 65, whatever. Right? Because they are 90 degrees out of phase. 90 degrees out of phase. Okay, relationship between the cosine and the sine. So again, on the cosine, you got to remember the points. What's the value of the cosine at 0? 1. It's at its max. It's at a crest. 90 degrees is 0, 180 negative 1, 270 0, 360 back up to 1. And again, just one last time here, if I trace around the dial, if instead now you'll look at the blue values, right? So what's the cosine of 0? 1, right? What's the blue value? How did that happen? All right, who knows? So you can see the value is 1, and I'm going around, right? And what's happening in the cosine? It's coming down, and I hit 90. And again, look at the blue value. The x-coordinate is 0 of this point. The x-coordinate now is what? Negative 0.391, and I'm going down and down and down. At 180, the x-coordinate is negative 1, and you're coming around, and you're coming up to the cosine. All right? Relationship between the sine and the cosine. All right, so again, you got to memorize the patterns. You should memorize them in degrees and radians. As long as you know that there's 2 pi radians in every 360 degrees, then you should be okay with the radians. But again, sometimes that's what they ask you to do. All right, so what happens if they say to you, graph the sine theta from negative pi over 2. So how many degrees is that? Because we think better in degrees. Negative pi over 2 is how many degrees? You guys don't have that one down yet? Pi over 2? Okay, that's like the beginning. That's negative 90 degrees. And we got to go to 4 pi. How many degrees is 4 pi? 720. You guys really need to be thinking through these questions so you can begin to get used to both situations. Okay, so I have to do the sine wave from negative 90 all the way to 270. This is the best way to learn how to do these. Just simply follow the pattern for every 2 pi. So I'm just going to take my blue here. And one thing we got to do is we got to determine, okay, so how am I going to mark the axis? And 4 increments is perfect for the sine and cosine. Why? Because I told you what are the key points. Starting point of 0, but then what do you have? 90, 180, 270, 360. See, 4. 4 works really, really well with the function. And so let's see. Let's go by 2s, though. We'll go by 8. So let's go first mark. We'll make that 90. And 90 is pi over 2. And go 2 more marks. And we'll make that 180, and that's pi. So you got 1/2 pi, 2/2 pi's. Go 2 more marks. And go 3 pi over 2, right? 3/2 pi. Go 2 more marks, and there's 2 pi. And now we got to keep going, right? Because we got to go all the way to 4 pi. So 1/2, 2/2, 3/2, 4/2. Next is going to be 5/2, right? 5 pi over 2. Then the next 2 increments is going to be 6 pi over 2. That's 3 pi. then 7 pi over 2, and then finally 8 pi. So 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, and then 4 pi. What did I say, 8 pi? You're all drinking Kool-Aid. Right? 8 over 2 is 4, right? 8 of them, 8 halves. So 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, and then 8 halves. And we also have to go backwards, right? 2 marks, which is negative pi over 2. Got to go backwards 90. So again, 1 half, 2 halves, 3 halves, 3 pi over 2, 2 pi, right? Which is 4 halves, 5 pi over 2. 6 pi over 2 is 3 pi, 7 pi over 2, and then 8 pi over 2 is 4 pi. Okay, if you're going to graph these, and listen now, where am I gearing toward? Here's what's going to happen. We're going to translate these. We're going to have different, and I should have mentioned this earlier, I'll mention this now, amplitude. We can change the amplitude. We can change the wavelength. And we can move the whole wave up, vertical. And we can move the whole wave left or right, horizontal transformation. So we're going to do all of that. And if we're going to do all of that, the best way to do all of this is to know the pattern and to graph them off the pattern. So I'm just going to take my blue, and I'm just going to run a vertical dotted line at 0, and I'm going to run a vertical dotted line at 2 pi. Why did I do that? Because the pattern runs from 0 to 2 pi, from 0 to 360. And now I'm going to take my red, and I'm just going to do the sign in that 0 to 360. So again, what are the key points? At 0 degrees, the sign is 0. So I put a point at 0, 0. In red there. At 90 degrees, the sign is at the maximum, so it's at 1. At 180 or pi, it's back to 0. At 270, which is 3 pi over 2, it's down to negative 1. And at 2 pi, it's back to 0. And I have just done the wave in this area. Now, how do I go all the way to 4 pi? Just repeat it. I repeat it. I already have the 0, don't I? Let me let you catch up. I see some of you still writing. Right? So you just connect the dots. So now, look here. Now we're going to go the next increment, right? Again, an increment of 360 degrees or 2 pi. And you do the exact same thing. Start at 0, we already have that point. At the first quarter mark, you're at a max, that's 1. At the halfway mark, you're back at 0. Okay? So first quarter mark, you're at a max. Halfway mark, you're at 0. 3/4 mark, you're at the minimum, negative 1. And then you end up back at 0. And there's the wave again, and just keep it going. Just keep it going. How do you go back 90? Okay, well, you can look at any of your waves here. We're at this vertical line, right? And I need to go back this way. So look from here. What happens when you go back? What happens when you go back 1/4 of the way? You end up at the minimum. Go back 1/4 of the way, you end up at the minimum. Now, you can do all of this with your calculator. You can plot the values if you want. You can do all of this with an XY chart. But if you try to do all this with an XY chart, if you don't understand what's going on, you could end up with a bunch of points just along the line and think you have a line. You can end up with this point and this one, and you don't know how to connect them. But again, if you understand the pattern and you graph off the pattern, then you can graph it. So the key is graphing off the pattern. And here, I should have mentioned this last time, so let me do it here. This value right here is the amplitude. We'll mention this again later. And by the way, it's the same value whether you go from the rest position up or the rest position down. It's the value of the amplitude. So if you increase your volume, that wave has a higher crest. And that's actually what's going on. Sound waves are waves. And more volume is a higher peak, a higher crest. Okay, let's do the cosine between negative 3 pi and 5 pi. Now again, on your paper you can see the pattern. I can't show it here just because it's a pain to try to do that. Okay, so again, I'm trying to do the same thing. I'm going 0 to 2 pi increments. 0 to 2 pi increments. On this one, it's probably easier to go one mark at a time. Again, if you look at the cosine, after the start, you have the first quarter, halfway, third quarter, and finish, right? So you have to start, first quarter, halfway, third quarter, finish. So that's what we want down here. So the easiest way to do this scale is let each mark be 90 degrees. So the second mark will be pi, right? First mark is pi over 2. I better mark them all. You guys will get confused. Pi over 2. Second mark is pi. We're going to scrunch this one up because we got to go all the way to 5 pi. Third mark is 3 pi over 2. And the fourth mark is 2 pi. All right, to keep from making it be a big pain all the way through, go 2 more marks. And now we're up to 3 pi. Go 2 more marks. And now we're up to 4 pi. And finally go 2 more marks, and now we're at the 5 pi. We don't need to show the in-between listing. We'll know what to do. All right, so from 2 pi, 2 marks, 3 pi, 2 marks, 4 pi, 2 marks, 5 pi. And so now backwards, you got to do the same thing. 2 marks back is negative pi. 4 marks back is negative 2 pi. And 6 marks back, 2 more from that one, is negative 3 pi. So we are scrunching up our view some, but that's okay. It's not a problem. We can do that. Oh, we got a lot to cover. It's going to be fun. I'm going to fly. Because it is what it is, and we've taken tons of days already. All right. So what is your pattern between 0 and 2 pi? So again, I'm going to take my blue, and I'm going to take these vertical lines between 0 and 2 pi. 0 and 2 pi. And I'm going to take my green. I'm going to do the cosine in that window using my pattern. How does the cosine start? At the max. So at 0, I go up to 1, I put my first green dot. At the first quarter mark, where's the cosine? Back to 0. At the halfway mark, what is the cosine? At the minimum, at negative 1. At the 3/4 mark, you got to be listening to what I'm saying and doing instead of just copying. Look, if you're just copying, you're getting 0. Zilch, nothing. You got to be listening to the words. So let me start again. At the start, you're at 1. At the first quarter mark, that's the first increment, you're at 0. At the second increment, the middle, you're at negative 1. At the third increment, you're back to 0. That's the 3/4 mark. And how do you finish? You're back up to the max at 1. That's the cosine wave in that increment. Now you got to reproduce that for the next 2 pi. And the next 2 pi, you only go halfway, right? We stop at 5. So you just repeat it. And you repeat it backwards. 2 pi. and halfway backwards in that second increment because we stop at negative 3 pi. So you're just repeating this pattern. You're just repeating the pattern. So now I'll work in the second area. It's already at a max for the start. The first quarter at 0. Midway is the bottom out at negative 1. Third quarter back to 0. Ends up at 1. Ending at 1 is the start of the next one. First quarter, I'm back down to 0. Halfway, I'm at negative 1, and that's as far as the wave goes. I'll connect those dots. Okay, that's 0 to 5 pi. We got to go backwards. So look at the pattern. That's why I gave it to you. What's the 3/4 mark? 0. Oh, right there. What's the halfway? Negative 1. What's the first quarter? 0. What's the start? Max. What's the third quarter? 0. What's the halfway? Min. Connect the dots. And by knowing the pattern, you're able to graph it between those segments. By knowing the pattern, you're able to graph it between those segments. Okay. I'm going to get a few more things in, and I think you'll be okay. All right, so I mentioned this already. The amplitude. The amplitude you'll find as a multiplier of the trig function. If you don't see anything there, the value of A is 1. All right, so the amplitude is A. That's kind of handy. And again, it's the amount the wave rises and falls above the rest position. The axis, right? The rest position is the axis. Or if that wave is translated, then it has to be the rest position. So you can see in our illustration, the amplitude is 2, right? This is 2. And it doesn't matter whether you're rising or falling, the amplitude is 2, right? Whether you're rising, it's 2, or whether you're falling, it's 2. So please pay attention to this. The amplitude is the absolute value of A. The absolute value of A. So if you come down here, what's the amplitude of A? 3. What's the amplitude of B? What's the amplitude of B? It's the absolute value of negative 4. It's 4. Amplitudes are always considered positive. Now, by the way, we already learned what a negative does, didn't we? Esther, I saw Esther doing this, right? Haven't we learned that negatives out in front of a function mirror it about the x-axis? So guess what the sine does if the sine has a negative? Instead of starting up and coming down, it starts down and then goes up. It flips it about the x-axis. Cool. All right. I'd love to go down there and finish more of those, but we don't have time. The second thing is the period. Number of degrees or radians in a complete wave. So here's the tricky part. You can see B is up there right in red. The B is the number of waves of the sine or cosine in every 360 degrees or 2 pi radians. The number of waves. It's the number of waves. So if you look at this first example, how many sine waves are there in 360 degrees? There are 2. If you were to write this, it would be y equals sine 2 theta. because there's two waves in every 360 degrees. But what would the actual period be? Well, the way you figure out the period is you take the normal amount, 360, to pi if you were doing radians, and you divide it by that b value. So we're going to divide by 2. All right, so there's a 2. And what is the period? 180 degrees. And isn't that the case? Don't we have a complete wave at 180 degrees? We do. All right, I think that's enough. The rest you're going to have to get from your book and read. I would have loved to fill in the rest. But that's as far as we can get. Quiz tomorrow.